Section 15B.2, question number 6, page 367. The question informs us that if y equals x cubed, then x equals y to the 1/3. In part A, we need to find dy by dx and dx by dy and show that those two derivatives multiplied together equal 1. So by differentiating, dy by dx just gives me 3x squared by using the simple power rule, and dx by dy is 1/3 multiplied by y, and then subtract 1 from the 1/3 to give me negative 2/3 as the exponent. Now I'll substitute the y with x cubed, and then I can just simplify here a little bit. So I get 1/3 x to the negative 2, because this exponent is 3 over 1, and when I multiply 3 over 1 times negative 2 over 3, the 3's will cancel, which will just leave me with negative 2 as the exponent. So now when we want to find the product of dy by dx and dx by dy, we see that 3x squared multiplied by 1/3 x to the negative 2 gives us 3 times 1/3 times x squared multiplied by x to the negative 2, and 3 times 1/3 is just 3 over 3, x squared times x to the negative 2 is just x squared over x squared, and we see that all of that just equals 1. So therefore, dy by dx multiplied by dx by dy equals 1 as required. Part B is asking why dy by dx multiplied by dx by dy equals 1 whenever the derivatives exist for any general function y equals f of x. So why would these two derivatives equal 1? So since y equals x, well, y equals x cubed and x equals 1/3, these are called reciprocal functions. Sorry, that is incorrect. These are inverse functions. Sorry about that. Therefore, we've got f of x and f inverse of x. When we look at those two functions, these are inverse functions, and these have reflective symmetry in the line y equals x. Therefore, the derivatives, the rates of change, or the gradient functions, are also going to be inverse functions, and they will also have reflective symmetry in the line y equals x. Therefore, when you take the product of the two gradient functions, they will always equal 1, just as the product of the inverse functions will always equal 1 due to that reflective symmetry in the line y equals x.